Let's welcome Steve Kosten.
Thank you, thank you. So today what we want to talk about is developing a secure software development lifecycle. I'm really happy to come out here today. I started off my career in engineering. I was in aerospace engineering. Then I migrated over to software, and then I eventually made my way into security, but I was a software Java developer for a long while. And when I got involved with security, my company, we do a lot of work with application security. And so what we do a lot of code reviews, we do a lot of application penetration tests, and we find a lot of vulnerabilities. We find a lot of the same vulnerabilities. And it gets really tiring to see the same vulnerabilities over and over. And so my colleagues and I were discussing this, and we decided we wanted to get out and really talk to the developers. And so to have the opportunity to come here, to come to Bulgaria, and to talk to software developers and talk to them about security is really exciting for me. Who I am. Really quickly, I'm a principal security consultant with Cypress Defense. I do a lot of instruction. Who's familiar with SANS at all? Okay, saw a couple hands. They make you pay through the nose, but it's good instruction, right? Who's familiar with OWASP at all? Thank you, thank you, thank you. I've been heavily involved with OWASP for a while. I headed the Denver chapter for about 5 years, and then I just gave that up because I think we needed new blood. I got some letters and things like that. But what I want to talk about, when we are dealing with developers and working with developers, a lot of times we found that developers have heard of different vulnerabilities, but they may not necessarily understand how to correct them, and they may not necessarily care that much about them, because you're under tremendous pressure to get code out, to get functionality out, and it may not be high on your list. And so what we wanted to do is talk about vulnerability and actually show you it, to show you how an attacker sees your applications. And so that's what we're going to be doing today. We're going to first start off doing an introduction to some security terms. I'm planning on showing you one attack right now. Time permitting, we can demonstrate another attack. And then we're going to be talking about the secure software development lifecycle. So, an introduction to security. Do I have assets that are at risk? You know, with Java developers, you guys have your own lingo. Security people, we have our own lingo. Let's talk about that a little bit so we're on the same page. It's a simple question, but what do we have? We have an asset and we have a risk. What is an asset? I think you have to be closer. There we go. Whoop. Went a little too far. Assets are things that we value. One, people. We value our people. Let me tell you a quick story here. It was kind of fun. I mentioned I used to work in engineering. I used to work with some of our defense firms. And we used to have a blue light in my company that if the blue light was flashing, it told us that there was somebody nearby who didn't have their security clearance. So we weren't able to talk about classified topics. There was another light, a yellow light, that if that flashed, it basically meant there was a gunman running around. That's kind of weird when they first told me about it, you know? But it was national security, this and that, and it's like, okay, cool. So my company partnered with another company, and I went to this partner company. I walked into the building the first day, and the yellow light was flashing. In my head, I'm like, oh my God, there's like a gunman, what's her? And I'm sitting here, and I'm looking, and the security guard is just sitting here, reading a magazine, like nothing's happening. I'm like, what's going on? It's like the yellow light. He's like, yeah, the yellow light just means there's somebody who's uncleared in the area. So they had actually swapped it on me, but anyways, I thought that was kind of fun. Other assets, we have computers, hardware, the stuff that we care a little bit more about. We have our data, we have our intellectual property. These are our assets. Let's talk about risk. Risk then is our assets, but measured by times our vulnerabilities, times the threat. The higher that each one of these goes, the more risk we have. So, if you don't have any assets, no risk. Who cares? I have nothing to lose. If I don't have any vulnerabilities, you are rock solid that there's nothing that's going to hit you, no risk. Does this ever happen? This never happens. It's like a herd of unicorns, flying pigs, everything. It never happens. What was that? Okay. What if you have no threat? You could be like the saints that everybody loves. Nobody's going to hurt you, right? Does this ever happen? This never happens as well. Same thing. So those are our terms. Now, on this next slide, we're going to talk about vulnerabilities. And we're going to play a little game. We're going to spot the vulnerability. Now, when I was talking with my colleagues about this, they were like, I don't know, Steve. You know, you're talking to developers. They're not trained in spotting vulnerabilities like you are. You know, this may not go over that well. And I was like, yeah, but they're smart people. They can figure this out. And we went back and forth, and I was like, all right, I'm counting on you guys. So I want you to spot the vulnerability. You set? All right, here we go. Anybody get it? Yeah. And when I first saw this picture, I just laughed. It was beautiful. And one of the reasons I loved it is, well, it's just kind of funny on its own. But as a when I was developing, we always think about happy path, the way things go. We don't really think too much about how people are going to abuse our systems. And that's what this guy did, who put this fence up. He's like, people are going to stay on the road and they're going to be driving straight up, and I'm going to put a fence down and I'm going to stop them. We have to start thinking beyond happy path. It's really easy to do. It's really easy to do when you're in a rush to develop, but we have to start thinking like attackers. We have to be thinking about the threats we will face in the environments we will face. I'm going to tell you another story here. I was reviewing an application, and it was a Flash application. And so I'm like, okay, I'm going to sit here, run the application, I'm going to watch the network traffic and see what's going on. And I logged into the application, put in my username, put in my password, and I watched the traffic go to the server. And in that traffic, I saw my username go across, but I didn't see my password go across, and I thought that was odd. And so I looked at it a little closer, and then I saw this encrypted jiggly mesh. I'm like, that's interesting. They're encrypting my password on the client side, within the application on the client side. Well, and I wasn't sure if they were encrypting it or if they were hashing it. So what I did is I just kind of changed my password, I doubled the password, and I watched the traffic go across again. And that encrypted jiggly mesh changed, it doubled in size. So that told me they were encrypting my password client side. I'm like, huh. Well, if you encrypt something, you need an encryption key, right? So I decompiled the code, picked out the encryption key, and then I had my colleague run the application as well. He ran the application, decompiled it, looked at the encryption key, and it was the same friggin' key. They were sharing their key across everybody. Bad news, bad news. So those developers weren't thinking about their attackers. Those developers weren't thinking about the people who were going to decompile the application. They weren't thinking about the people who were going to be monitoring the network traffic and trying to figure out how the application works. You guys have attackers right now. They have attacked your applications, they are attacking it now, and they will be attacking it in the future. And you have to start thinking about what these people are going to be doing. One more thing, who are our threats? We have disgruntled employees, we have contractors. I didn't even plug in my... We have the random person in the basement, we have our organized criminals, hacktivists, nation states, and each of them have their own motivations. We have someone who's upset with their company, revenge, random person in the basement, just an opportunity to attack. Organized criminals are going after financial. Hacktivists have their own goals and so forth. But let's think about how it used to be. It used to be so nice. It used to be our attackers, our threats were just like a burglar, you know? It used to be someone who just walked by our house, saw that our window was unlocked, and just came in and rifled through our stuff. It was somebody in our community. It was our next door neighbor. It was someone down the road. It was nice and easy. But who are our threats now? It's the whole world now. It's the whole, well, darn world. So that makes it a lot harder. Because how many vulnerabilities do they need to break into your system? Typically just one. Okay, some more stories. Remember there was a distributed denial system, it was like in October 2016, it brought down most of the US internet. I don't think it really affected Europe at the time. I'd have to research that. And the cause of it was a botnet. And it was really because all the Internet of Things, all these new devices were coming on that were rife with vulnerabilities, immediately compromised, and they were used to cause a distributed denial of service. And this got somebody thinking. This guy at The Atlantic, this magazine, Andrew McGill, he wrote an article, The Inevitability of Being Hacked. And for this article, he did an interesting thing. He got a virtual toaster, and he put it online. How long did it take for that toaster to not only be scanned, not only to have an attack put on it, but to be attacked and compromised? 41 minutes. Someone compromised a toaster in 41 minutes. What about your applications? Do you think they're not being targeted? So, let's meet somebody. George. George was really upset with Mozilla, you know, Firefox, because he ran he was in charge of the technology for a company, and Mozilla messed with his site. Here's his letter. He posted this on a forum for Mozilla, and this forum, of course, was wide open for everybody to see. Your notice of insecure password and or login automatically appearing on the login for my website, Oil and Gas International, is not wanted and was put there without my permission. He's angry. He is angry. Please remove it immediately. We had our security system and it has never been breached. It's been up there for 15 years and never been breached. He's angry. What's he angry about? Mozilla had the nerve to say that it's not secure because he's not talking over TLS. He's not encrypting this traffic as the users go to log in. He's not encrypting it. Uh-oh. It gets worse. It's not just individual users, it's corporate company logins as well. By the way, cheers to the cameraman. I'm making him do a lot of work because I'm moving around here, so. So, what's the worst that could happen to him? We'll come back to that. Let's see talk about some vulnerabilities. A1 in the OWASP top 10 is injection. It's when we, in writing our applications, we accept input from users, from other companies, from other sources. We have to make sure that we treat this input as untrusted, because we expect to treat this data as data. We don't expect to be receiving commands and execution commands from our users. But our attackers will want to do that, and that's what injection is. It's when the interpreter takes untrusted data and actually uses it in execution. I love this one. Ever get really mad when you're speeding and you get those automated tickets? Just once, I'd love to see them drop their database. Or 1 = 1. Target was compromised, 110 million records. I could sit here and go all day talking about compromises from injection, but we're not going to do that. We're going to look at it really quickly. So here we have, under command injection, we have a lot of different types of injection. We're really used to SQL injection right here. We also have command injection, XML injection, a lot of different types. But enough talking about it. Let's just see a demo. Let's see an exploit. Now, we're going to be using a tool called SQLmat. Who's familiar with SQLmat? I see a couple people. It's nice. It's a tool. I'm trying to see how much I paid for that. Got to pull up the receipt. Oh, it's free. Let's go see what we can do with this. Give me a second. One second here. Let me make sure everything's running. Yes, this is running. I don't know why it's not displaying right now. I'm going to just restart my VM real quick and see if it comes up. Yeah, this is really a pisser. Okay, I'm going to try restarting this now. I've been doing this on and off. Oh, something just flashed there. I've been running this VM all day. And it's a display issue because I've been doing it all day. Interesting. Okay, if this doesn't go, I'm going to talk through some of this stuff, and but it really stinks because this is a fun demonstration. You guys don't have any idea about this, do you? Pardon? Yeah, I just quit the VM and, oh yeah, I'll force quit that, I'll try that. Okay, I'm going to go in, keep going without this, if this doesn't show. I'm going to try restoring a snapshot too right now.
Are you trying to run this full screen?
Am I trying to run the VM full screen? Not right now. I did have it full screen, but I can't even get it going straight. Okay. We got that going. I might have to reconfigure it here because I just restored to a previous state. Let me go back here and see where I am. So I'm going to demonstrate SQL injection. So let me just open that project really quick, fire it up. And now you know this is not a canned demonstration because it's failing. All right, we should be fired up right now. Let me pull up the browser. Let me pull up my demonstration. Okay, so what we're going to do, we have our application. I'm doing a search for 42, and it's pulling up case number 42. Okay, that's kind of what's expected. Let's think what an attacker does. We do 42 bang, put a quote in there. And I'm getting an error in the application that says, hey, there's a SQL syntax. That's interesting. So maybe I can mess with it. Maybe I can do 42 or 1 equals 1. We love things like that. We do a search. And we have some errors again. It's 42. Now, I put in 42 equals 1, or 1 equals 1, and I don't know if you can see this, but I returned case number 3. Why did it return case number 3 in this case? Anybody? Because I'm returning result set, right? And what did that or 1 equals 1 do? It says, or something's true, of course, it returns the first case in the result set. But I'm only returning one thing, right? Can I do anything really bad with this? At worst, I've compromised user ID 3. Does that really matter? Can anybody else be compromised? Let's find out. So I'm going to be using the tool Burp Suite. Who's used Burp Suite or proxy? This guy does stuff. I like you. So this is a free tool. There's a professional version as well, but it's allows us to see all the traffic that's going on between your browser and your web application, your server. And so right now in Firefox, I'm configured with no proxy. I'm going to put burp in the middle right now. So I'm going to resend this thing right now. I have my proxy on. I'm just going to let that go forward. And over here, we're going to start seeing a history. So this is what your users are doing, your attackers are doing. Let me run this again. I'm going to do a search for 42. And I can come into my proxy, and there's this post here. And I can see in here that the case number I'm searching for is 42. So your attackers are seeing all your network traffic, all the requests, every single web service you're running, all your web service calls. And we do this all the time when we're inspecting applications. We want to see what web services you're calling. Are you authenticating those services? That's a huge issue. Are you authorizing them properly? We find all sorts of issues here. But in this case, I am going to save this item. And I'm going to save it to training. I'm going to call it SQL.request. Okay, now I have SQL map installed here. And so I'm going to go into my directory, SQL map. And we're going to run the tool. So what I'm going to be doing is SQL map, and let me zoom this a little bit so you can see. Can you guys see that better? You're welcome. All right, so we got SQLmap.py. So I'm going to run this tool, and I'm going to send in their request, which I have at /home training, and I think I called it SQL.rec. And let's see. Because I kind of screwed around getting this thing going, I'm going to give it a little cheat here. I'm going to tell it what the backend database is. DBMS, MySQL. Okay, so I'm going to run this tool. It's just asking me some questions. It's asking about a parameter it sees in there. It sees that, hey, have MySQL. Do I want to keep going? Yes, I do. And so it's testing this request I saved off in Burp Suite. So I used Burp Suite. I intercepted a request from my application. I saved off that request, and I'm sending that request into SQL map. And you can see down here at the bottom, it says, hey, case number is vulnerable. That number is vulnerable to SQL injection. Do you want to keep going? Well, do I need to keep going? I know it's vulnerable right now. Who cares? I just need one vulnerability. So now, I'm going to stop this. Let's do another command here. So I know that it's vulnerable. So let's do this again. We're going to specify that, hey, let's see what databases there are in there. Boom. So it is querying the backend database for me, and it's saying, hey, there's a customer service database, there's an e-commerce database. Oh, by the way, there's a MySQL database. That person is running as a privileged user. That's good for me to know. I can sit here and query all of the backend databases. Okay, so we have an e-commerce database. Okay, so let's say, let's query that database, say I want to find out about e-commerce, and hey, give me the tables in there. Here are the tables in that database. Pretty cool? So are we just getting one record back? So let's see, we're getting the tables back. Let's find a little bit more about that one table, customers. So let's keep going with e-commerce. And let's say, tell me the columns in that database. There we go. Anything interesting in here? Anything you guys want to see? Address, ooh, CC number. I wonder what that is. Well, screw it. Let's just make this easy. Let's dump that database. Now I'm just getting all of that information from the database. That's kind of cool, isn't it? Do you guys see me sweating right now? Was that really hard work? Do you think there's a lot of people doing that on your applications, automatically trying to find SQL injection vulnerabilities? Yeah. I reviewed an application. This application had been online forever. I had just started it, and I found a SQL injection vulnerability on the login page. Who can see the login page? Remember that whole world? So I'm literally 5 minutes into starting this review, and I call our customer and I tell him, hey, by the way, I'm dumping your entire database right now. And he's like, oh shit. Yeah, because it had happened before. Yeah, we always say that there are two kinds of companies, two kinds of organizations. There are those who've been hacked and know it, and those who've been hacked and then don't know it. So, what do we do for mitigation on this? We do parameterized queries. We do use our object relational mappers. We have to do things parameterize them correctly, not simply just, and we must not simply use stored procedures. I've had a long number of people tell me that, hey, we're using stored procs, we're good. We must make sure things are properly parameterized. This is a way not to do it. They're taking untrusted data being passed into the stored proc and executing that. I just did a review last week where they initially didn't provide me with the stored procedures. I asked for them and saw they were doing this. They had been vulnerable for SQL injection for a long, long time. So remember George, who had never been attacked and has never been breached in 15 years? After he posted this, he just put his company in the spotlight. So people immediately started posting that, hitting his site, they immediately found a SQL injection vulnerability. And someone immediately freed him from the liberty, freed him from having to maintain that database anymore, because they just dropped the database. Poor George, 15 years without a breach. All right, so what do we do about this? Like I said, we teach, we really want to see us handle security and get security into the life cycle. First part is just getting training. I love the fact that you're here because this is just kind of refreshing. If you had, I'm sure you're familiar with SQL injection. Maybe you hadn't seen how easy it is. Maybe you can start using some of these tools to test some of your applications, or you can just look at your code and make sure you're doing it properly. So, no matter what, whether you're doing waterfall, agile, you're always going to have these steps in your process. You're going to do some kind of requirements, whether it's a user story or not. You're going to do some kind of design. You're going to immediately do development and verification and testing. Core security training is really just getting some base level of security training to your development teams. And we really want to see this because the more we can have our developers do and become more well-versed in, the more we can free up our security team and our experts from having to deal with some really common mundane things. We should all be aware of security and be working on it. With our user stories, we're working with a company right now and they're doing development for their clients. And we're saying, listen, let's get us involved early. As you're starting their development, as you're getting the architecture in place, as you're getting the first frameworks in place, let's think about how we're going to authenticate our users. Let's think how we're going to authorize our users. Let's think how we're going to be reviewing all untrusted data and validating it before we use it in our applications. We're going to be doing a risk analysis. Are we going to be asking our users to send their password each time? How are they going to be passing their information to us? We want to have risk analysis as we're doing that. And we're going to see risk analysis happening throughout the life cycle. We're always thinking in the terms of risk. We're always thinking about how someone is going to be threatening our application. When we get into development, one of the things we like to do is seeing automated reviews of the applications, static reviews. Static tools, like check marks and Fortify, are really good to get into the automation side. They do take a lot of time to run, unfortunately, and they do generate a lot of false positives. But the nice thing about getting some of this static analysis, the secure code review being done as you're developing, is it gets the results in front of you right away. You can find the vulnerabilities, the silly mistakes that we all make, and correct them right away. As we get through, we want to get involved with the penetration testing, having our security team test that. Again, we're going to be working and getting our attack surface reviewed. So how are people going to be viewing our applications? Is there anything we can do to minimize our exposure to our threats? And we're always trying to minimize that. And throughout this whole process, we're going to be doing continuous monitoring, continuous feedback. So, yeah, we kind of talked about this. I'm going to go into the next slide. The big thing we do want to do, again, is iteration. Who's doing continuous integration, continuous deployment? Yeah. Are you guys, what are you guys doing? Can anybody throw out what you guys are doing from a security perspective with that? Are you guys using static analysis tools? Okay. And how's that working for you guys? Yeah, reading the reports takes a long time and it's a lot of problems. That's one thing my company has really been working with. These tools can be very helpful, but as I mentioned, huge number of false positives. We've kind of reviewed applications in multi-millions of lines of code, and it literally takes days to run. Days. And when it does run, you get a nice report, and typically what the security team does is they take that report and they drop it on the developer's desk and say, fix it. I've seen some of these reports. They are 5,000 pages. I can tell you there is no way you're going to have a development team hate a security team so much as when you drop a 5,000 page document on their desk and say, hey, check this out. One, you just piss them off. Two, they're not going to do it. So kind of what we work on and what we're trying to get people to do is we really tweak the rules, especially in a CI/CD environment. We tweak the rules so they can be run quickly, and we find out which rules are giving us true positives at a confidence rate of, say, 95% or higher. Those are the only ones we're going to put in front of the development team. Because if you put false positives in front of them, everything is a false positive. Everything is a false positive. So what we really emphasize is getting true positives in front of the development team. Let the security team kind of work on the process, improve the process, tweak the rules, get better rules, so that you're not overwhelming the development team. And the one thing we like to emphasize is we have to make it easier for the development teams to utilize security. Rather than give you a report like that, get the true positives out, so that your development team knows that, hey, this is something that's wrong, this is something I need to fix because it's a true vulnerability. And we don't give it to them in a report, we integrate back into their issue tracking system, whether using Visual Team Studio or what. Get it back into their normal workflow. Because one of the things I've learned about people, and this is not unique to developers, especially true of me, we're lazy, right? We want to make it as easy as possible to do our stuff. If you make someone jump to a huge PDF document and try to find the true positives, it's not going to happen. We have to make it easy for them to do the security. And don't give them, the security teams cannot give them so many false positives. So, I apologize, my little issue with the VM kind of threw my presentation timing off. I was going to talk a little bit more about some other things. But the one thing I just really wanted to emphasize to you guys, and hopefully just walk away with, you are being attacked. You have been attacked, and you will continue to be attacked. You must think like an attacker. You cannot think happy pass. You have to think about the risk your application will face. You have to think about who is going to be attacking you. What is their motivation? Are they just going to spend 5 minutes looking at you, and if they don't find a vulnerability, they're going to move on? Or are they going to have teams of attackers working and studying your application to find the vulnerabilities to break in? I think I'm out of time right now, but I'd love to open it up for questions, comments, if anybody has something they want to throw out. Yes? The question was, what static analysis tools do I use? We use a number of different tools. The big ones that we most commonly use are Checkmarx and Fortify. Fortify is really good in one sense because it's been around the block the longest. And when I put both Checkmarx and Fortify head-to-head in a new application, typically Fortify will find more vulnerabilities. The one thing I have to say about Checkmarx, though, is that it makes it really easy to tweak the rules so that if you find a vulnerability, you can tweak the rules easily and find more. And perhaps more importantly, if you find that you're getting a lot of false positives, you can tweak the rules really easily and get rid of a lot of false positives. So I think Checkmarx still has maturing to do, and it's as it's getting a little bit more widespread, it's doing that, and it's developing better rules. Right now, I'd say Frontier wins as far as finding more vulnerabilities, but it's kind of harder to use, harder to use overall and harder to tweak. Any other questions? Okay. Thank you for having me, and apologize for that.